Hello and welcome to section 11.2, which is on the surface areas of prisms and cylinders. So a prism is a polyhedron with two congruent parallel faces called bases. Other faces are all lateral faces, and you name it by the shape of the bases, because all prisms have two bases. So if the bases are triangles, you would call it a triangular prism. The altitude of the prism, which we might need to find because that might be the height that we need. It's the perpendicular segment that joins the planes of the bases, and the height is the length of that altitude. A right prism is the lateral faces are rectangles, and a lateral edge is the altitude. An oblique prism, some or all of the lateral faces are non-rectangular, and the lateral area of a prism is the sum of the area of lateral faces, and the surface area of prisms would be the sum of lateral area and the area of the bases. So using that, I am going to look at this little prism I have drawn here, and it is a triangular prism that is right here, and then in the back here you can see the hidden edges. So the first thing I need to do is find the area of my bases. And so since we know the longest side, the hypotenuse, can never be one of the bases, I'm going to use the 5 by 5 for the two sides I'm going to use for my area of a triangle. Half base height, half 5 by 5. So half of 25 is 12.5, but then there are two bases, so if you take that times 2, you're back to your 25. So I'm going to keep track of that over here because I need that. Then I need to find the area of all three rectangles. So this front side here is 12 by 5, so that would be 60. Keep track of that. The back side is also going to be 12 by 5, so there's another 60. The bottom is going to be 12 by 6, so that would be 72. Because the area of rectangles is base times height, so that's pretty basic. So I get 217, and make sure that we label it with square centimeters. So you're simply finding the area of each face and adding it all back together for surface area of prisms. Theorem 11.1, lateral surface area of prisms. So the lateral area is the perimeter times the height, and P means the perimeter. They're talking about perimeter of the base. Surface area is the lateral area plus 2 times big B, which is area of the base. Okay, so the big B, this should be a big B right here, is area of the base. So here's my example. What is the lateral area of a regular hexagonal prism with hexagon sides of 6 meters and a height of 12 meters? Okay, so if we look through that, what are we going to have to use for that? Lateral area. So lateral area equals perimeter of the base times the height. And so since the perimeter of a hexagon, you would take one side times 6, so it would be 36 for perimeter of the base, and my height is right here. So all I need to do is take 36 times 12. I would get 432 square meters then for lateral area of a regular hexagonal prism. If it wasn't a regular one, obviously you would need more information to be able to do that. What is the area of the base in simplest radical form? Okay, so to do the area we learned in last chapter is going to be 1/2 of the apothem times perimeter. So we already know perimeter. Perimeter is 36 because we just found that right there. So we need to find the apothem. And if you think about just a real roughly drawn hexagon, if this side down here, hang on a sec. If this side down here is 6 then halfway to that, to the middle, right? And then out. So the apothem is going to be right here. And so since halfway over there would be 3, then the apothem is going to be 3 square root 3. So you take 1/2 of 3 square root 3, and this was using our special triangles, special right triangles that we learned before. So 1/2 3 square root 3 times our perimeter, which is 36. And so 36 times 3 is 108, and I still have my square root 3 there. Half of that is going to be 54, and so 54 square root 3 meters squared. And I'm just going to leave it like that. It says simplest radical form, so that's how I'm going to leave the answer. What is the surface area of the prism? To the nearest whole number. So the surface area, if you go back up here and look, it says lateral area plus 2 times area of the base. Well, we just figured out the lateral area and the area of the base. So we have everything we need. So I just need to take 432 plus my 54 square root 3 times 2. And if I go ahead and multiply that all out, I'm going to end up with a total of 619 square meters. This one does not say leave it in radical form. It says nearest whole number, so I can go ahead and multiply that all out, and this is what you get. Some more terms. A cylinder is a solid that has 2 congruent parallel bases that are circles. The altitude and the height is a perpendicular segment that joins those bases. A right cylinder is a segment joining the centers of the bases. The altitude, the segment that joins the centers, is the altitude. An oblique cylinder, the segment joining the centers of the bases is not perpendicular to the bases, so those are a little different. Theorem 11.2. Lateral area of a cylinder is 2 pi r squared, or excuse me, 2 pi times radius times height. And then the surface area would be 2 times pi times radius times height plus 2 pi r squared. Keep in mind, pi r squared is the area of a circle, and then obviously you'd have to take it times 2. You're taking 2 times area of the base, just like in that last formula. But because it's a circle, it's always pi r squared. So lateral area of a cylinder, the area of the curved surface, and then the surface area of a cylinder is the sum of the lateral area and the area of the 2 bases added together, which is what this says right there. So if a cylinder has a height of 9 centimeters and a radius of 10 centimeters, what is the lateral area and the surface area of that cylinder? So we should have everything we need to be able to figure this out. So lateral area equals, go back up here and look if you don't remember, 2 pi rh. So 2 pi rh, and then surface area is going to be 2 pi rh plus 2 pi r squared. So there's our 2 formulas. So I just need to plug some numbers in here. 2 times pi, we're going to use 3.14. My radius is 10. My height is 9. I just need to do some math. So 2 times 3.14 is 6.28, and 10 times 9 is 90. Multiply those two together, you get 565.2 square centimeters. We're going to use that for this formula, right? Lateral area is what this is right here. So I've already done that part. So I can just put in there equals 565.2 plus 2 times pi times my radius, which is 10, and I'm going to square that. So 565.2 plus 2 times 3.14 is 6.28, and then I have the times 100, which I could just take care of right here and be done with it. So 565.2 plus 628 equals, and I'm not saying to round it or anything, so I'm just going to go ahead and add those, 1193.2 square centimeters. That is my surface area of a cylinder. So bring that knowledge with you, and we'll talk about it more the next time I see you. Have a good night.